All right. Well, can we turn our attention to the birth of the new mythology at this point?
Well, as I say, all right, so we're getting into the 70s, and after the discovery of the cosmic microwave background, the Big Bang starts to become a dominant theory. Now, again, it's already pretty unscientific because people like Amo and Dickey and other prominent scientists had predicted that there would be some radiation in the universe as a result of the Big Bang. That was a really vague prediction because people already knew that there was radiation in the galaxy. There had to be. Basically, bodies at any temperature are going to radiate something similar to a black body spectrum. So the question was, if you want to make a prediction, what is that temperature? Because one number does describe any black body radiation, and that number is temperature. So the temperature is directly linked by the black body formula to the amount of radiation. Take the amount of radiation, and it varies as the fourth power of the temperature. So so the question is, what is the amount of the radiation? We know it's going to be out there, and therefore, what is the temperature? They're mathematically linked. So what were the predictions? Well, Gamow said 50K, 50 degrees absolute. Dickey said 5K. So what was measured? 2.5K. So if you want to look at Dickey, how close was it? A factor of 2 in the temperature, factor of 16 off in the radiation density. Not too good. I mean, you could throw a dart as easily. Look at Gamma, 50K. That was the most publicized prediction because it was actually in one of his popular books.
Right before the discovery of the CMB as well, I might add.
Right. And so these were true predictions. So 50K, 20 times error on temperature and 16,000 times error on energy density. So were these verified predictions? I mean, come on. But the media took it and ran with it. And, you know, there was a lot of rewriting of history. I mean, you can really compare the published papers with what people said afterwards. And they did backdate some of their predictions pretty badly. So first of all, you have two things happening. The CMB saying it's not the steady state. And, maybe it is the Big Bang. And this is a popular field. Second thing that came in at the same time was the discovery of quasars. Quasars were ultra dense, ultra energetic explosions extending over tens of thousands or hundreds of thousands of years. And some of these same people said, "Oh, this is a fire. This must be um, black holes. This must be hyper condensed material because what else could produce this?" So this was exactly the same argument that Lemaitre had used about the Big Bang. What else could have produced it? So in this process, Alfvén was shifting his attention from inside the solar system, partially because he had won the argument, and Alfvén was interested in the most controversial parts of the science that he could contribute to. So he started looking at the galactic and supergalactic scales. And during this period, I think we're moving into the 80s, he developed a completely different model of the quasars. From this question, he went back to his research in the 30s, explaining cosmic rays, explaining how gigantic electric currents must be moving through the galaxies to explain their observed magnetic fields, and saying at the center of these galaxies, you could have an enormous concentration of energy electromagnetically, and that could power these enormous beams, just like the enormous energies of the cosmic rays could be powered purely electromagnetically. From there, he went to address the Big Bang. And first he addressed it methodologically, basically doing the cosmological pendulum description and the fact that this was mathematical myth. And it's very important to say a mathematical myth is just as mythological as a myth written in English or Hebrew or Aramaic, because mathematics is a language. Part of this mythologizing was a mythologizing of math itself, that math was something supernatural. Really, they're really talking about it as a supernatural force. Mathematics is a language. It's a quote unquote universal language because people are all around the world use the same symbols. So is musical notation. People all around the world, I think, use the same musical notation. It's a language that people have developed to describe scientific theories because two things. One is it's a compact way of describing quantitative concepts. Quantitative concepts can be described in other languages. 1, 2, 3, 4 is quantitative concept in English, but it's very compact. And the second thing, which makes mathematics different from other languages, is that a true statement in mathematics has to be logically consistent with the rest of the mathematical system.
Our videos come out of LPPFusion's research in fusion energy, energy which will power a future of abundance for all, with a sustainable economy and a clean environment. Goods, housing, and transportation will be affordable to all once fusion kicks in. Fusion energy is the key to building a better world now. Support fusion research, $10 a month at lppfusion.com/support. The link is in the description. Thanks.
In English, perfectly good English statement can be, well, he's an idiot, but he's not. So anyone saying that, clearly it's a logical contradiction, but it would have pretty clear meaning to anyone who was a native English, fluent English speaker. But you can't allow that. That is not a valid mathematical statement. If you can prove that some statement is the equivalent to A and not A, then you say QED, this is invalid. And if you can prove that it is consistent, you can say QED, it's proved. It doesn't mean it describes reality. A good English statement is, I was visited by a fairy just now. Perfectly good English sentence, but has no relationship to the truth, to validity. And you can make valid mathematical statements that have no relation to reality, such as the mathematical underpinnings of the Big Bang. The universe is expanding, can be described mathematically, but a universe that isn't expanding can be derived mathematically. But one of these statements is true, and that can't be determined mathematically.